Welcome to the next installment in my video lecture series for Principles of Microeconomics. And in this particular video lecture, I'm going to be taking a look at a potential test question that could appear on test number 2. And it's from chapter 14, the oligopoly chapter, and in particular it has to do with game theory. So it states, using the below payoff matrix, determine whether any dominant strategy or Nash equilibrium exists. Explain your answer in detail. So if we get rid of that, we have a larger version of that payoff matrix. And let me just review what exactly a payoff matrix is. A payoff matrix lists the potential strategies for, in this example here, two participants or two people competing against one another. So we have A and B are competing against one another. In this particular example, it would probably be convenient to think of this as two firms that are duopolies, the two large firms in a particular marketplace. So they exist in the same marketplace, and they have, let's for simplification purposes, only have two different strategies. All right, they can either come to an agreement about fixing prices, so both parties could adhere to the agreement, or B could adhere to the agreement and A could decide to cheat, and there's payoffs associated with that outcome. Or B could decide to cheat while A adheres to the agreement, and this quadrant here, this area, shows the payoffs for A and B if A adheres to the agreement and B cheats. Or B could cheat and A could cheat, and it lists out the payoffs if they both engage in that strategy. So there are 4 different ways that this game could play out, and what the payoff matrix does is lay out those 2 different strategies for the 2 different combatants or firms in this particular marketplace, and the outcomes for each individual outcome that could occur. So if we take a look at this, one of the things that you're asked to do is determine whether or not either firm has a dominant strategy. So one of the things, the way to do that is just to pick one firm, all right, and assume that the other firm holds to it, adhering to the agreement. So one of its strategies is to adhere to the agreement. And so if A adheres to the agreement, let's take a look at the 2 strategies that B can engage in and see which one is better. So, for example, if A adheres to the agreement and B adheres to the agreement, their profits will be $5 million. If A adheres to the agreement and B decides to cheat, B is going to have profits of $8 million. Therefore, if A decides to adhere to the agreement, the best strategy for B is to cheat. Let me get rid of these. Because B would much rather make $8 million versus $5 million. So if A were to adhere to the agreement, the best strategy for B is to cheat. Let's change this and assume that A cheats. What's the best strategy for B to engage in if A cheats? Well, if B adheres to the agreement, they're going to lose $2 million. But if they decide to cheat right along with A, their profits will be $2 million. So therefore, B is better off cheating when A cheats because their profits will be $2 million versus losses of $2 million. Therefore, regardless if A adheres to the agreement or cheats, B is always better off cheating because their profits are always higher when they cheat, irrespective of the strategy that A engages in. Let's do the same thing for A. So we're going to do A and take a look at, let's assume that B adheres to the agreement. So B is adhering to the agreement. What is the best solution for A when B adheres to the agreement? If A agrees to adhere to the agreement and adheres to the agreement, A will have profits of $5 million. If B adheres to the agreement and A decides to cheat, A's profits will be $8 million. Therefore, if B adheres to the agreement, A's best strategy is to cheat because their profits will be $8 million when they cheat versus $5 million if they adhere to the agreement while B adheres to the agreement. Let's do the same thing. Let's hold cheating constant for B and see what happens and what is the best strategy given that B cheats. So if A adheres to the agreement when B cheats, they will incur losses of $2 million. If they decide to cheat when B cheats, their profits will be $2 million. So again, they are better off cheating. When they cheat, when B cheats, their profits are $2 million. But if they maintain an adherence to the agreement when B cheats, they're going to lose $2 million. So A is always better off cheating. So A has a dominant strategy of cheating, and B has a dominant strategy of cheating. So this is a dominant strategy, and this is a dominant strategy. Let's assume that we are at this point right here, that both firms adopt the dominant strategy, and the outcome is that both firms make a profit of $2 million. Does either A or B have an incentive to deviate from that dominant strategy? Okay? For example, if B decides, well, I know that we're both cheating, but I'm going to go back to adhering to the agreement. What happens to B's profits if A remains cheating and stays as a cheater, and B decides, I'm not going to cheat anymore, I'm going to adhere to the agreement? Their profits fall from $2 million to losses of $2 million. So B has no incentive to deviate from cheating when A is cheating. Let's take a look again at this as both parties have a dominant strategy. Does A have any incentive to deviate from the strategy? Well, if A goes from cheating to adhering to the agreement while B maintains cheating, what happens to their profits? Their profits go from $2 million when they cheat to losses of $2 million when they go to adhering the agreement when B is cheating. So realize that there is no incentive for either party to deviate from the cheat equilibrium. If A decides to cheat and B decides to cheat, there is no incentive for these parties to deviate from that. Therefore, this is considered a Nash equilibrium.